In today's video, we are going to look at experimental design, both how individually to design an experiment, but also how to interpret the results of an experiment and ensure that everything was done correctly when the experiment was performed. So scientific discovery relies upon experimentation. In order to either perform an experiment or analyze the results of an experiment, you must understand the different variables in and requirements of an experiment. So all experiments begin with observations. You observe the world around you, and from these observations, you ask yourself a question. And of course, anytime you ask yourself a question, you try to come up with an answer for that question. And that's our first key term here, a hypothesis. So a hypothesis is a proposed explanation for a set of observations. Now, hypotheses are not just random guesses. They're what we'd call in the vernacular language, educated guesses. An example of hypothesis is I try to turn on the TV to watch the Little League World Series, which is currently on TV, but the TV's not turning on. First thing I think is, okay, maybe the remote is out of batteries. So my hypothesis is, if I replace the batteries in the remote, then the TV will turn on. And notice, the hypothesis is an if-then statement. If I replace the batteries in the remote, then the TV will turn on. Notice two other things about the hypothesis. One, it's testable. I can test this simply by replacing the batteries. Secondly, it's also falsifiable. If I replace the batteries and the TV still doesn't turn on, I've now falsified that hypothesis that the batteries were responsible for the TV not turning on. These two components have to be part of a hypothesis for it to be a valid hypothesis. It must be testable and falsifiable. So now that hypothesis has been defined, I want to use an example of an experiment to define the other variables that are part of experimentation. So here's the example, and this is a true example. There's a Labor Day brisket competition at the neighborhood pool that I attend. Because I want to win the competition, I need to test a few recipes ahead of time to determine the tastiest recipe. Each of 3 variations of the brisket recipe will be tested by a group of 5 friends who will rate each of the 3 on a scale of 1 to 10. Right? They're simply going to test it by tasting the dish. Now this is important right here. So I'm going to star the brown statement here. The 3 recipes have the same base ingredients. The beef brisket cut, which is from the chest area of the cow, salt, pepper, paprika, white vinegar, and chili powder. The only difference between or among the 3 recipes is how that brisket is sweetened. Recipe 1 uses table sugar. Recipe 2 uses brown sugar. Recipe 3 uses maple syrup. So our experiment has been set up. Now, we're going to break down this experiment into its individual parts. So the first thing is the control variables. These are the variables that stay constant, or in other words, remain the same, in all three of the recipes. We could also call the recipes the treatment groups. That word will come up, so you'll want to be familiar with treatment groups. So they're variables that stay constant in all three recipes. So the control variables would be beef brisket, salt, pepper, paprika, white vinegar, and chili powder. Those are your control variables. The reason we need to have control variables is if those are changed and then the friends go and rate the briskets and say, oh, this one's better than this one. We don't know if it's better because of the ingredient that sweetens the brisket, or if it's because we changed one of these other ingredients. We have to keep those other ones constant in order for us to know that whatever sweetens the brisket is responsible for the brisket tasting different. Every experiment is going to have control variables, and you need to define what those control variables are and ensure that they remain constant among all of the treatment groups. The second variable to define, I'm going to put in green here to match up with the green in the text. This is the independent variable. And this is the variable that we change, or in other words, manipulate among the treatment groups. In this case, the independent variable is how the brisket is sweetened. So table sugar, brown sugar, maple syrup. Those are different in each of the three recipes, right? A different sweetener is used, so that is the independent variable. The sweetener is the independent variable. It's the variable manipulated by the researcher. So that leaves one other type of variable, which is the dependent variable. And this is what responds to the change in the independent variable. I'll abbreviate it IV. The dependent variable in this example is going to be the number the recipe receives on a scale of 1 to 10. That number will depend on which of the sweeteners is used. It doesn't depend on any of the control variables because those are the same in all three recipes. If we just didn't use any sweetener, all three recipes would be the same because they'd have the same exact variables. The only thing that can be responsible for difference in taste is the sweetener that's used is the independent variable. So the dependent variable responds to the change in the independent variable. And in this case, it's what number that recipe receives on a scale of 1 to 10. Note, there's only one independent variable, and there's only one dependent variable. There will generally always be multiple control variables, because there's a lot of things you have to keep the same between experiments and treatment groups. But the independent variable, for any valid, good scientific experiment, there should only be one independent variable. Because if you change more than one thing, you don't know what is responsible for the change or for differences between the groups. So make sure anytime you're looking at an experiment or you're performing an experiment, you identify and define your control variables, your independent variable, and your dependent variable. And the entire design of the experiment all comes from the question, that turns into your hypothesis. So for this example, my hypothesis could have been, if table sugar is used for the brisket, it will score a taste score of 9. If brown sugar is used, it will receive a score of 10. If maple syrup is used, it will receive a score of 8. That's my hypothesis, and I simply test it now with the experiment.